Alright, how's it going, everybody? I'm going to do a quick video on detention time here. But one of the things that I've been kind of ignoring is the fact that when you're doing your math problems, that you should have your state's, what is it called, the equivalence and formula sheet in front of your face when you're doing it. You're going to be given one on the test, so you might as well study with one. If you study the way you're going to take the test, then chances are you're going to feel more comfortable during your test, and you're going to be more successful, especially doing the math, which seems to be the hardest part for a lot of people. I have two sheets here. I got one is the ABC formulas and equivalence tables here. You can see here there's 1, 2, 3, 4, 5, 6 pages of just freaking lot of garbage here. You may use 8, 9 lines. I mean, chances are you're going to take a test that's going to have 8 or 9 problems, whatnot. Are you really going to use a lot of these, especially for a grade 1? You're not going to see any horsepower questions. You're not going to see any, you might have to calculate that. You probably won't see any chemical problems. Do you really need, if you don't know the area of a rectangle, are you really going to succeed on your grade 1 exam? I'm not sure you are. But if you don't know how to do area, it would be a good time to learn it before you walk into your exam. You can see all the stuff. And then I have the California sheet right here. I don't know if they've updated this or not. It's 2 pages long. It's got some loading. It's got SVI, chlorine demand. A lot less stuff in here. When I originally took the California test, they pretty much just gave us this, and that was about it. But the problem that we're going to be doing today is detention time. And so you can see the formula for the detention time on California's sheet right here. And you can see here you got your volume in cubic foot, your conversion factor 7.5, even though right here it says 7.48. I don't know why they're rounding on their own formula sheet, but I personally only use 7.48. Then they also put this 24 hours per day in their formula. I don't really like that, because not all detention time problems are going to be solved in hours. Some are going to be solved in minutes, some are going to be solved in days. It all depends on your flow rate and the size of your tank. And you got your flow rate here in gallons per day. Notice how this is not in million gallons per day. That's going to be important. I want to show you what it looks like on the ABC formula sheet. The ABC formula sheet right here just says volume over flow. Units must be compatible. So if you don't know what a detention time problem is, you're not going to have any clue when you see volume over flow and they give you, you might get an easy one where they just give you volume and flow and you just divide the two numbers and you're good to go. It should be, but you're not going to get your answer straight off of the formula sheet, and you need to know how to use the formula sheet. Knowing where the conversion is, because at first you're not going to know that 1 cubic foot of water equals 7.48 gallons. At first, that's not going to stick in your head. But over time, it will stick in your head the same way 1 gallon equals 8.34 pounds. The 7.48 and the 8.34, those numbers can get jumbled. You should know where these numbers are at on your formula sheet, just in case you freeze during the math portion of your test. Same thing, it's a little bit easier to find on the California one because it's not at the very back. You got your 7.48 right here, and you got your 8.34 right there. Know where it's at, know how to use your formula sheet. So detention time itself is the amount of time that it takes for 1 cell of water to make it from the entrance of the tank to the exit of the tank. So I drew this little picture here. Probably a rectangular clarifier or something like that. I put a weir here. That'd be a weir. That's what that W is. So basically what you're looking at is when one cell of water enters here, one cell of water exits here. So really what we're doing is we're comparing the flow rate versus the volume of the tank, and we are going to figure out how long it takes for the water coming from this way to push out all of this water so that that first cell can make it out the end. And realistically, this is probably not going to be 100% accurate. I mean, it will be for the test. The test, in the world of tests, the math just works right. But I mean, you could even look at my picture here. You're going to have a dead spot underneath this pipe. You might have a dead spot along this corner here. You might have a dead spot under the weir. You might have a dead spot back here. You might have sludge building up on top of your pipe. You may not get an exact what is actually happening. You might have to account for the fact that you're going to be losing some volume in this. But realistically, for the sake of math, you're just gonna do the math. Don't get too confused by dead spaces or anything like that. It's more of something that you need to take into consideration when you have a tank that may have a bunch of trash at the bottom. Maybe the detention time of your digesters has reduced and you're not getting the gas production that you used to be getting in an anaerobic digester. You might need to clean out the bottom of the tank because it might have a bunch of rags or trash or grit or whatever on the bottom of it. But this is what we're looking at. I mean, one cell here, one cell here. You got to push out all this water for that one cell to get out the back door. So I got damn it, I was supposed to have all this hidden. But I got this problem here for you. Calculate this out. You can pause the video if you want and just get your answer. I'm gonna roll here in a sec. So the first step that you got to do is you got to make your units match. You have 100,000 cubic foot, 3 million gallons a day. How do we make these things match? Well, we're gonna meet in the middle. We're gonna convert both of them to gallons. You can see here I got that 7.48 number that I was talking about. You're going to times that by your cubic foot, and it's going to give you this many gallons. And then your 3 million gallons per day, you're just going to write that out as 3 million. This way you don't forget it later when you're doing your math. You don't want to screw this up, because if you do not make this conversion, your number will be 1 million times higher than it should be. Your second step is to divide the two numbers between one another. Got it solved here. So this is kind of what I was ranting about that California exam sheet. But you have your two numbers here. Did I get the right amount of zeros? 1, 2, 3, 1, 2, 3. Yep. So I got about a quarter of a day here. Then when you're converting from days to hours, know that your days and hours are going to have to be logically sound. Like you see a quarter, so you're either going to, the conversion is going to be 24 hours per day. So you either have to multiply this number by 24 hours, or you're going to have to divide this number by 24 hours, depending on which way you're going. If you had minutes, you would actually multiply it by, you'd actually divide it by 24 hours a day to get hours. Because Jesus Christ, you wouldn't be using, if you had minutes, you wouldn't be using hours per day. God damn it. I'm very tired. I went to the Royals game. It's 3 hours away and it was 100 degrees outside. So I'm a bit dehydrated and my brain's not really working today. But we have a quarter of a day here. It should be roughly 6 hours when you make your conversion. If you go the wrong way and you divide, this number is going to go down to 0.00 something or other. It's going to go down to what? Maybe probably 0.1. I don't know. Not a calculator. I'm not a calculator. But your third step is to convert. I shouldn't have ranted about converting. And so you can see here 0.598 I didn't get my units right. Yeah, I mean, like I was saying, a quarter of a day, it's going to be roughly 6 hours. You got roughly 6 hours there. You didn't mess up your conversion. I wrote the units down wrong. That could cost you, if you don't have multiple choice math, that could cost you a point. That could cost you a point. You got to watch out for that. That is a good example of how not to lose a point. I got another problem here. My brain will start working here in a second. What is the detention time in hours of a rectangular tank with the dimensions 10 foot by 30 foot by 16 foot if the influent flow rate is 900 gallons per minute? So, I mean, you just grab this right off your flow meter. And that's where that number came from. I mean, it is what it is. Sometimes they won't give you units in million gallons per day. But you got to find your volume of your rectangular tank. And that is not it. That is it. I got it 4,800 cubic foot. I mean, that should be pretty easy math for you. Step 2, you have to make your units match. So, you got, I mean, really, our gallons per minute is already in gallons. So all we had to do was convert the cubic foot to gallons, and then you have gallons. It's actually much simpler step 2 from the other problem because it didn't have the 2 MGD screwing everything up. Step 3, you're going to divide the two numbers together. I mean, it's the exact same formula as the other one. So when I divide gallons by gallons per minute here, I just get my answer in minutes. Then step 4, I'm going to have to convert this to hours because the problem asked for it in hours. So you have to divide your 40 minutes by 60 minutes per hour, and you get 2/3 of an hour, which, I mean, so one of the things I wrote as a note here is it seems like a really dumb way to express the answer because nobody talks about 0.66 hours when they're talking about time. You don't say, how long is it gonna take you for you to drive here? Oh, it's gonna be 0.66 hours. I'll be there in a little bit. 0.66 hours. Google Maps tells me it's 0.66 hours with the traffic. It's gonna be 0.75. It's I mean, telling somebody that you're gonna be there in 40 minutes is a much, much, much better deal. But for whatever reason, this will have shitty answers like this. It will. And I took this problem from a sample question sheet from the state of Rhode Island. And, yeah, I mean, they wanted their answer 0.66 hours. I don't see what's wrong with it. But depending on your state, depending on who wrote the test, if I wrote your test, you might have to solve for this in minutes. You might have million gallons per day here. This might say 1.2 MGD or something like that. And you might have to solve for minutes for me if I wrote the test. But Rhode Island, you're going to need to find 0.66 hours. You need to pay attention to what the question is asking for your units. And you need to make sure those units are there at the end. Or else you'll end up like me on the first problem and actually get the question wrong because I said it was 3.6 days instead of 3.6 hours. Two completely different answers, really. If your boss asks you, hey, calculate this out, and you tell them, oh, it's going to take 3.6 days to fill, and then your boss says, okay, we can leave the hose running for the weekend, and you go ahead and leave the hose running in the tank for the weekend to fill the tank or whatever, you come back on Monday morning, things are going to be overflowing, and you're going to have 2 days worth of water on the ground, and it's going to be your fault, and your boss is going to be pretty mad at you because you didn't get the units right. So, I mean, realistically, wastewater operators aren't going to be doing a lot of math calculating for fill times, detention times. That's another thing, too, is if this tank is empty, you can use this exact same formula to figure out how long it will take for you to fill this tank completely. It's the exact same formula. And it's just instead of using your flow rate, you're using, well, I mean, you're still using your flow rate. Instead of pushing one cell through the empty tank or through a full tank, it's going to push it through an empty tank. And I know there's going to be things like head and things like that that might actually slow down your flow of water, but realistically, they're the exact same problem. So if I said, instead of what is the detention time, I said how long would it take to fill an empty tank with these exact same dimensions and the exact same flow rate, your answer is still 40 minutes. I mean, it's the same exact problem because the volume is the same, the flow is the same, everything's the same. You just have an empty tank instead of a full tank. Now I got a different problem. I actually copy pasted this from that same Rhode Island page. So you can pause it. I don't really want to read this out loud because my brain hasn't been working and there's too many words there. Step one, you got to make your units match. So we have some feet there, circular clarifiers. So you're going to have to find the volume of a cylinder, basically. I mean, it's pi r squared times height. That's how I got that. Again, like, I don't want to be a basic math teacher. I want to be a wastewater math guy. You should know how to find the area of a cylinder. This is one of the things that you should be prepared for the state exam. Then we're just going to convert the cubic feet to gallons after finding the volume of the tank. We have a volume of 300,000 gallons. We had 2 MGD. We want to make sure that's 2 million gallons there. Step 2, we're going to divide the two numbers. This is the exact same formula. Just because I gave you the problem as a paragraph instead of a data drop, you know, I mean, you got this is the exact same problem. You should feel comfortable doing these. These are beginner level wastewater grade 1, grade 2 questions. You should be able to put the gallons over the gallons per day. Remember, when you have a fraction in between a fraction, this actually, the gallons will cancel out and the days flips to the top because you're dividing a number that is dividing by, that's already being divided. And so it's negative multiplication. Negative times a negative is a positive, so the day goes on top. It's very confusing. But and I probably shouldn't be saying things like that because it is confusing. But that's how days comes to the top of this, because this is 0.15 days over 1 technically. But realistically, you have a calculator, you put 300,636 over 2,000,000, and you're going to get your answer, which is 0.15. Just pay attention to your units, and when you're on your scratch paper, keep track of your units, because you don't want to lose your units and then say, oh, it's 0.15 hours. We actually need what, like 24 clarifiers to get our detention time the way it is. But next, we're just converting. I mean, this is the same formulas, same stuff. Just timesing our days by 24 hours per day. Cancel out the days. Leave ourselves with hours. We get about 3.6 hours. Step 4, this is where this is more of a problem. The step 4 is going to be more of something you would see grade 3, grade 4, grade 5 type question, because it's asking you not the detention time itself, how many clarifiers do we need to get the detention time of 3.5 hours. So with one clarifier, we're running 3.6 hours. If we were to run 2 clarifiers, that would cut our 3.6 down to 1.8, because our flow is going to be split in half, and we're not going to, or no, it's going to double it. It's going to double it. I'm sorry. My brain is not working. It'll double your detention time because you're going to slow the flow rate through each clarifier. If you fed each clarifier out of the 1 million gallons, then what you're basically doing is you're cutting this number in half, and you're going to get 0.300636. And you're going to get yeah, you're going to basically double this number here, which is going to double this number. So you're going to get 7.2 hours. So that's not right because that's going to be way too slow. So your answer is just one clarifier. I mean, that's where you have to use logic, and sometimes they will make you use logic on these math problems, so it's not just numbers; it's a real world solution. Yeah, so you have 7.2, and then you'd have 10.8 hours if you use 3 clarifiers. But we want 3.5. We get 3.6 out of 1. 1's good enough. That's the way that problem goes. Again, that problem, credit that problem to the state of Rhode Island for putting that one together. That's great, isn't it? Thanks for watching the video. If you made it this far, appreciate it. I hope you pass all your tests. I hope you make $1 million in this field. I mean, you'll never make $1 million, but you make a decent amount of money to be able to pay for a house and have kids and have a wife. I mean, it's a great field. So keep working at your math, pass your grades, get your certificates, and keep moving up the ladder. I'm going to get out of here. Have a good day.